All right, welcome back, my little lima beans. We are going to carry on with our adventure through, not adventuring, yes, adventuring through trig identities. I understand that they can be kind of scary. You might feel underqualified, but don't worry, that's totally normal. That's how you're going to feel for the rest of your life. So you might as well get used to it now. I had a professor once who told me, you don't know what you're doing? You don't feel like you've understood everything? Oh well, fake it till you make it, bro. Verbatim, he said that, more or less. So don't worry about it. Honestly, these things are a matter of kind of you use it or you lose it. So the more you practice, the better you'll get at it. And then someday you'll be great mathematicians. So let's talk about verifying trig today. Today, what we mean by verifying is I'm going to tell you the answer, and we have to just make sure that it is the answer. So you know the answer. It kind of gives you a sense of direction. That should be super helpful to us. Okay, so before we start doing that, I want to teach you a couple of new trig identities, and then we'll be good on trig identities for a little while. We'll add maybe a couple more, but not many more past what you learned last time and these ones. So these are what are called the co-function identities. These ones I feel like are probably the most obvious ones, but not the way they're written, right? So let me just kind of show you something real quick. If we say, all right, here's 1, here's -1, let's graph sine, right? It goes up to a max, comes back down, does this. Yeah, that's super ugly. This probably won't look super pretty when we're done, but it'll give you the idea. Then let's graph cosine. So cosine should look something kind of like that, right? If we take the cosine graph and we shift it so that this maximum meets up with this maximum, if I were a better artist, do you see how these two things perfectly overlap? Perfectly. 100% perfect. That's not a mistake. So what you can do is you can take any cosine function and you just scoot it over however much that is. And then, ta-da, now you're a sine graph, right? You could do it backwards too. You could also take your sine graph, scoot it over like that. And then again, you can see that they perfectly overlap. But that's the gist of it, right? Sine and cosine are the same thing, just scooted over a little bit. So that's kind of what we're saying here. We've got sine of 2 pi minus theta equals cosine of theta. This might look a little backwards. Let me rewrite this. So sine of negative theta plus pi over 2. Okay. This negative here does some stuff. If you have a negative b value, it does do some weird things to your graph. It actually flips it horizontally. But don't trip too much about that. Just recognize our horizontal shift is 2 pi. Sorry, not 2 pi. Back up. That's something else. Our horizontal shift is our h value, which is negative pi over 2, divided by b, which is -1. So this is pi over 2. So basically what this is telling us is if we take a sine function, scoot it over pi over 2, it turns into cosine of that same angle. Okay, that's all you're trying to learn here. So all of these say that if we take this trig function, scoot it, it turns into this one. If we take this one, scoot it, it turns into this one. Because you can do that with sine and cosine, it shouldn't be a surprise we can do it with secant and cosecant. And then tangent works even better. Tangent, it's really important that that negative exists here, that one. Because, like I said, having tangent of negative theta, this negative takes your tangent graph and turns it from this into this. Hold up, let me see if I can do this. right? It just flips it upside down. It's actually flipping it like left, right, but semantics, you know what I mean? You scoot it and flip it and it turns into that. So the way you're going to recognize these, they're going to be just blindingly obvious. You're going to see a pi over 2 inside a trig function with a theta. And then on the other side of the equation, it'll be just thetas. That's like a giant screaming trigger warning, right? It's like, please use the co-function identities. And then you'll know because it'll be on one side and not on the other. And then you have to do that. Cool? All right. So let's talk about our general strategy going into this. And then we will do, I believe I have 4 examples for you. Top tier, really super fun. You can pay me later. My Venmo, PayPal, and whatever else you kids send money on nowadays is in the description. Make sure you check out my Patreon. Really helps the channel. Like and subscribe, blah, blah, you know. So here's our strategy going forward. You want to start on the more complicated function, and you're going to try and simplify it. This is what we did in the first lesson. We're going to make something scary looking look not scary. That's strategy number 1. Okay. This kind of goes hand in hand with tip number 3, is try and only work on one side at a time. So if you have scary stuff equals nice stuff. Okay. When you're doing this on a piece of paper, it's going to be like, you're going to take your scary stuff and you're going to turn it into like sort of scary stuff. Okay, and then you'll put in equals and then just leave this blank. We're going to just drop that thing down at the end. Then your sort of scary turns into not really scary. And then you're going to take same stuff, right? And then your not really scary turns into okay stuff. And then your okay stuff will eventually turn into nice stuff. And then you'll be like, oh, look, nice stuff equals nice stuff. And then you'll call it a day and you'll be done. That'll be it. Ta-da, you did it. Okay? So you're going to work on the more complicated side and simplify it. You're going to do this one side at a time. You're going to see multiplication occasionally. The first step is not multiply always. Sometimes it's step 1, use trig identities. And then step 2 is multiply. Okay? This isn't algebra 2. You don't just get to look at what math operation is sitting on the page and then blindly beat it to death with that math operation. You're going to have to think a little bit and go, if I do that math operation, will the scary stuff turn into nicer stuff? Or will it turn into more scary stuff? Right? If the answer is more scary stuff, don't multiply first. Try and turn it into something a little nicer first. Okay? Our last tip here is going to be have a goal in mind. Because you're going to have stuff equals nice stuff, your goal in mind is the nice stuff. However, if you see something with like a tangent of x, a cotangent of x, and then you see over here sine, you want to think to yourself, how can I turn this into sine, right? You want to make a sine somehow. So the fact that this side has a sign on it is a big hint that you should use that one, right? That's what we mean by have a goal in mind, is look at what you're supposed to get and then try and turn this into that. Force it to be that and think, there's a sign here. Where did it come from? Oh, probably from that tangent, right? Tangent is just sine in disguise. So things to be aware of. Okay, let's just get our fingers into it. Let's dig into the nitty gritty, get some, dirt on our fingers, stuff under our nails. That way we got something to chew on later, All right, so let's start with this first one. This is a nice, easy one, nice little babby problem to get you guys started. So we want to take cosine of pi over 2 minus x times secant of x and turn it into tangent of x. Okay, think to yourself, which side is scarier? Is it this one? No. I knew it. I knew you guys were right. Of course it's not this one. This one is one thing with a variable, no coefficients, no fractions, no nothing, right? So it's not that one. Okay, we're going to start on this scary looking side. You've got to face your fears, okay? You can't just hide behind your mom's leg at the grocery counter all the time. Sometimes you're going to have to talk to the lady at the register yourself. So what did I say about it being super duper obvious? Like, hey, use that trig identity I told you about. Do you see how we have a pi over 2 minus x here and we don't here? That's telling us we want to use one of our new co-function identities. So cosine turns into sine. And these aren't very easy to get mixed up, right? Cosine turns to sine, secant goes to cosecant, tangent goes to cotangent, right? They're all paired up with their appropriately named things. So this cosine, we're going to turn that into sine of x. Okay, now we have secant of x equals tangent of x. All right, so we're doing good. Now we're trying to get tangent. I know tangent is sine over cosine. Oh, look, I already have the sine. It's right there. So how can I get an over cosine? I wonder where it comes from. So now we need to remember some of those trig identities from before. This is one of our reciprocal identities. This is going to turn into 1 over cosine of x times sine of x equals tangent of x. So this is sine of x over cosine of x equals tangent of x. And oh, well, what is sine of x over cosine of x? Tangent of x. There we go. So we have verified that these are, in fact, the same thing. Congratulations, you did your first example correctly. All right, let's go check out another example. All right, so this one, ooh, this looks scary, right? This looks like something we're gonna have to call someone for. But unfortunately, they called me and you're stuck with me, so sorry. All right, so we're gonna start again on the scary side. And now there's a bunch of stuff here. Let me warn you against your instinct right now. This secant squared does not cancel with that secant squared. That's not a legal move. If you're going to cancel top and bottoms of fractions, the entire top needs to have the thing in the bottom you're trying to cancel it with. So if you have like 4 plus 2 over 2, it's not like this, right? Whoops. This 2 goes into 4 2 times. This 2 goes into 2 1 time and equals 3. If you do this the long way, this is 6 over 2, which is 3. So it should still work out the same way. If you just cancel these, you get 4, which is obviously wrong. So you cannot cancel these. That's an illegal move. So what are we going to do? There are multiple ways we can do this problem. And you know what? It's kind of whatever. It's up to you. The thing that I recognize from my last pro tip in the last video is that I have a trig function squared and a 1. So let's investigate this, shall we? I don't remember this trig function exactly, right? But you have a list of them somewhere on a piece of paper. This one is not on there. Let me show you which one is on there, though. The one that's on there is tangent squared plus 1 equals secant squared. This is what you're going to see. Note, though, we can subtract 1 on both sides and get tangent squared equals secant squared minus 1. So what we're going to do is we're going to take this whole secant squared minus 1 and we're going to replace it with a tangent squared. Okay, cool. So this is tangent squared. Are you guys okay with, I mean, you don't have a choice because it's my video, but I'm going to omit all these thetas. I'm going to write just tangent squared instead of tangent squared theta, because this is going to get real tiresome if I have to keep writing that theta. Okay. It's there, just it doesn't matter. Over secant squared equals sine squared. We'll put the theta in at the end. All right. So now we think to ourselves, all right, I'm trying to get to a sine. I better turn this tangent into something with a sine in it, right? So tangent equals sine over cosine. Tangent squared equals sine squared over cosine squared, right? Tangent squared is just tangent times tangent. So it's just sine over cosine times sine over cosine, right? Okay. So I'm going to turn this into this. All right. So we're going to have sine squared over cosine squared over secant squared. Okay. Equals sine squared. All right. I need to get rid of this cosine somehow. Guess what secant's made of? Cosines. So let's go ahead and make our reciprocal substitution here. So we're going to have, oops, hold on, I messed up my pen for sure. Okay, so we have the top still. We have sine squared over cosine squared over secant can be replaced with 1 over cosine squared. Secant squared, cosine squared. All right, equals sine squared. You're thinking, Barton, this is getting worse, not better. But look, a fraction divided by a fraction, we're going to flip and multiply. So we have sine squared over cosine squared times, flip this, cosine squared over 1. The cosines cancel, and we have sine squared equals sine squared. Put the thetas back in. Sweet, huh? And that's really what you're going to be doing. You're going to have to take these. You're going to have to massage them. You're going to have to really get your elbow in there to get those knots out. You're going to have to take a step back, put some more lotion on your hands, look at the back, identify where the knots are, and then massage them one at a time with patience. Okay? You can't just go into these problems and start karate chopping this problem's back to death. That's going to make their back hurt more, not be a nice massage that leaves them feeling simplified, at peace. You know, you've got to really massage them. You can't just beat them up. All right. We're going to do 2 more just to really, really drive home the point and to give you some examples, because I get that these aren't easy and they take a lot of like seeing before they start to stick. So I'm going to try and give you good examples and then give you some good practice problems. So here, we're trying to turn this thing into 2 secant squared theta. All right. So the first thing I notice is that this thing is not a fraction, and I notice it's one thing, not 2 things being added together. So let's go ahead and just do the addition here. Okay. So if I want to add these, I have to have a common denominator. So we're going to multiply the top and bottom of this fraction by the denominator of this one. 1 plus sine, 1 plus sine. And we're going to multiply this fraction on the top and bottom by the denominator of this fraction, which is going to be 1 minus sine, 1 minus sine. Okay. So the tops are just whatever this is, because 1 times anything is the anything. So this is 1 plus sine over. When I FOIL this out, do you see that this is the thing I showed you about before? A plus B times A minus B. It's this thing plus something else times the same thing minus the same something else, right? This will always simplify to a squared minus b squared. The a times negative b and the b times a, those terms in the middle cancel each other out. So this is going to be 1 minus sine squared. Cool. Here on the top, plus sign comes down. On this side, the top is just the top because 1 times anything is the anything. On the bottom, it's the same two things we multiplied here, so it's going to be the same answer, right? That's the goal, right? We're trying to get a common denominator, so that should happen. And then this equals whatever that stuff is. We're going to just ignore it for now. All right, so now we can add these. Because our denominators match, we can have this common denominator on the bottom, 1 minus sine squared. 1 plus 1 is 2. Sine plus negative sine, it's like 2 plus negative 2. They cancel out. Dang, that looks way better, right? We have that 2 now. Ta-da, we've got a 2. Now we have to somehow get a secant squared. So it looks like that secant squared has to somehow come from this 1 minus sine squared. So right now you should have a big red flag in your brain. Right? There, red flag. Big red flag flapping in your brain, screaming at you that you have a trig function squared and a 1. That's 99% going to be a trig identity, right? So let's go figure out which one it is. The only one we know with sine squared in it is the one that everybody knows with sine squared in it. It's going to be sine squared plus cosine squared equals 1. But we have 1 minus the sine squared. So we moved the sine squared over. So this is cosine squared equals 1 minus sine squared. So there's our 1 minus sine squared. We're going to turn that into cosine squared. All right, so we have 2 over cosine squared equals 2 secant squared. Okay. Let's ignore this 2 for a second. How do I turn something over cosine squared into a secant squared? This is just the reciprocal identity, right? Secant equals 1 over cosine. So pretend for a second that this is 2 times 1 over cosine squared. We can turn this into secant squared. And then we're done. So that's 2 secant squared x, or is it theta? Always make sure it matches. It's x this time. Equals 2 secant squared x. And there you go. All right. On to the very last one. So this one also looks a little scary, right? Now the question is, which side is scarier? Is it tangent plus cotangent, or is it secant times cosecant? That's a tough one, right? So I know how to add things together better than I know how to turn multiplying into adding, right? If I have 1/2 plus 3 over 4, I can turn that into like one thing easier than I can turn the one thing into two things. You feel me? So I'm going to go ahead and say that it's going to be easier to go this way than that way. And if you don't immediately have that same gut reaction that I do, this is just one of those things where you need to do a lot of math, right? I feel that way because of the volume of math I have done. The only way for you to also feel that way is to do a large volume of math, which means you have to do your homework, okay? So trust me on this one, and then I'll give you homework so you can go get your own volume, all right? You got to do those reps for Archimedes or something. So, all right, secant and cosecant, these things are cosine and sine in disguise. This is 1 over cosine, and this is 1 over sine. So we're trying to get sines and cosines. So let's turn our tangent and cotangent into sines and cosines, and then maybe we'll go back, right? We're going to go tangent, sines and cosines, secants, or something like that. This is our general flow chart for trying to solve this problem. So we're going to use our ratio identities. That's probably not the actual name of them, I forget. But tangent is sine over cosine, plus cotangent is just the reciprocal. So cosine over sine equals that stuff. We'll worry about that later. Now, we have two things. We're trying to turn them into one thing. So let's go ahead and get a common denominator just like we did last time, and this will be a lot easier. So this side, we're going to multiply by sine. So we're going to do sine and sine. This side, I've got the sine on the bottom. I need the cosine. So we're going to do cosine and cosine. All right, this is looking nice. And if you don't see why it's nice, you will in a second. So sine times sine is sine squared over sine times cosine, plus cosine times cosine is cosine squared over sine cosine equals some stuff. Aha, right? I feel like, have you seen that Pixar film? Or it's one of the pre ones for like Toy Story where the guy is playing chess with himself and he's like, aha, that's what I feel like. So sine squared plus cosine squared. This is like the only identity your mom probably knows. Sine squared plus cosine squared equals 1. So sine squared plus cosine squared is 1 on top. And then our common denominator, sine, cosine, equals stuff. Okay. Here's where we need to care about the stuff. We need secant and cosecant. Hang on. Secant and cosecant. This is just a thing of fractions. I understand that you guys are all terrified of fractions. You're as scared of fractions as you are of talking to that boy or girl you like. Let me explain fractions to you real quick. This is the same thing as 1 over sine times 1 over cosine. You've just multiplied them together and turned them into 1, right? You multiply the tops together, you multiply the bottoms together. Same thing. Let's use this. 1 over sine, oh, that's cosecant. Whoops, not cosine. Cosecant. 1 over cosine, oh, that's secant. Okay, and then the order doesn't matter. Multiplication is commutative, so there. So there you go, you're done. And then, of course, throw back in your x's, right? Make it look nice for mom. There you go. Cool, and you're done. So hopefully these 4 examples have kind of given you a glimmer onto the magic of trig identities and how you should be going about trying to solve them. If you still are terrified because there's fractions everywhere, there's things that aren't even math, right? These are letters, little phrases. Sin, my mother told me never to sin. It's a sin, right? Don't worry. It just takes practice to sing correctly, children. So if you need further instruction, you're confused as to how to go about solving this enigma that is trig identities, hit up the WebEx. Ask your highly trained professional math teacher to help you with their problems. And I'll see you guys next time. Make sure you like and subscribe, won't you?